it somewhere else. It's going to give me the result back saying that it's 5th through 9th of February 2021. Definitely an obsolete data, right? Because the model which I'm using is the model which got trained probably a year ago. That's why it cannot fetch me what is relevant. So this is definitely hallucination we talk all about, right? Though it is not relevant, but still from its knowledge, it's trying to provide me some information because it is a generative AI. It generates content for you, right? Now let me take this same question to one of the OpenAI implementation which is live today called Bing Chat, or we can call it Copilot. So you can also use this. Alright, it's a free tool. You can just use your Microsoft account and then that personal account and then ask this question here and see the experience. Increase the size. Now you can see that now it is more relevant, right? Because there is a match happening on this month, right, March, and it's giving me the difference. Now, probably it is using the same model behind the scene. Now, I know it is using GPT-4. I haven't used GPT-4, but that's a different story. Even if I use GPT-4, I'll still not get the data, right? But assume that they are using the same model. But how can it give you that information? And that applies to a very specific thing about, like if you ask this question to GPT model which is deployed in Azure, let's say right now at this point in time, what is the weather in Bangalore? It cannot provide you that information. It will tell you that I don't have the information because it doesn't have the current information. You can ask about the incident which has happened yesterday, right? It will not fetch that information for you because it was trained before that incident has happened. Now, this is able to provide you that information. Why? Because though it is using a read-only model, but it can use the data which is the Bing search collecting over a period of time. So Bing is a search engine, right? So it crawls the internet and then collects the data. So there is definitely a data source available. It is using that data source to make sense out of it. And that's where the enterprises needs LLM for. They say that I don't care about the internet data because that's not the data I am looking for. Imagine that you are a healthcare industry. Your data is never in the public internet, right? It will never be in the public internet. So how do you use your own data to use the same LLM to make some sense out of it? Think of it like a human brain. When we get trained in mathematics, let's say you learn calculus, okay? Now you might appear for an exam and see a problem of a calculus problem which you never have done before. But because you are trained to do the calculus, right, you know what formula could be applied here. And you try those approaches and you're eventually able to solve the problem, right? Because your brain knows how to interpret that problem. The exact same thing. So the LLM is like a brain. It is trained on a data, but it may not be aware of the data you want the LLM to act on. So you can use this as a brain to fetch the information from your internal data and produce the output. Now, to help you understand, I need to draw a little bit. Now when you talk about LLM, right, you think of it like your car engine, right? Which means that is important, but that's not everything. If someone sells you a car, you can't use that as a car. You need a lot more other things. So when you talk about LLM, it's all about application. That's why ChatGPT becomes so popular because you could use it. Earlier, LLM was there, right? But it was more of an academic, right? People who used to do PhDs and all these things, they were able to play with that with a very limited capacity. And it was never trained with large amount of data, etc., etc. But the moment ChatGPT came, it becomes suddenly a big buzz because you could play with it because you have everything else. Also the LLM, right? So think of it like your central piece here. That's your large language model, which is generating the content. That's the purpose of generative AI, to generate the content. It could be text, it could be video, it could be audio. Now you have an interface. It could be a web interface where you write the question, right, and then you hit a button. Now, what we don't do in the enterprise context or the old data context is that we don't hit the LLM directly. We don't do that. Because you have seen that it can fetch pretty still information, and in fact for an enterprise it will not be able to fetch anything, right? Because there is no data. If you say that, tell me the history of this employee, how can it find that information from the web? Probably it will find something from LinkedIn data which is not relevant, right? Because you have same name people with many LinkedIn profiles. Now, why we don't do it? Because the data is irrelevant and it is not trained against our data. Now, how can we solve this problem? Now, there are a couple of ways to solve the problem. Is that you can build a good prompt. That's the number one. Good prompt. But even if you build the best prompt of the world, you still will not be able to fetch the data because that data is not available. Right? Second approach is with what we call as fine-tuning. That means you take the LLM model, you retrain the LLM model with your data, and create a LLM model with those memory and the nodes and everything with your data, and then you eventually end up using that LLM. But enterprise data grows in every second in transactional world. Now we have to train it, and training is an expensive activity. It is like building an electric grid for your home electricity. It's not a practical approach, right? So we don't do that. We don't encourage that. There are organizations who does that, but we don't encourage that. So, and then the third approach is that we use something called a retrieval augmented generation, or RAG. You will hear this term again and again. It's a pattern, and I'm going to explain that pattern here and show you how it changes the experience when you implement that pattern. And remove it. Now, what do you need? First of all, you need data, your enterprise data. So it could be stored. I think I could use the red one because it came out. Yeah, it got stuck. Black. So in the enterprise scenario, you have data stored in many different data sources. So you have files, you have databases, you have third party, you have web services, you have other things, right? So this is the set of data in an enterprise. In any and many format. Now we need to do a little bit of work. Think of it like a data warehouse where you build a reporting data warehouse. You need to do something, right? So that is similar. So before you hit the LLM and this, so now you build an application, you go to your chief data officer and say that I want access to all your data. They will say thank you very much. We're not discussing. Nobody will give you access to any enterprise data. Now how do you build that? Now over a period of time, many enterprises build their own data lake, which means that they put the data in the data lake with proper access control list, which means that if I'm not a manager, I should not be able to see my peers' salary information. If I'm a manager, I should be able to see the salary information of people reporting to me. Right? These are the access controls they have put. So that means the data lake is ready to be consumed by individual who has got certain rights, and only that amount of data is readable for me. Right? So if I even search, it will not fetch me. So it is protected. So you imagine this is a data lake now. Now you need something in this process called a vector store. As the name suggests, this is exactly the same vector as we have learned in the mathematics, right? So it basically stores the characters of your data. It could be an image, it could be an audio, everything in an n-dimensional vector array. It's typically at, I think, 1536 dimension, 1536 or something around that number. That's the dimension of the vector. So every sentence or word, no matter how small or big it is, if you vectorize it, it becomes that many dimension of that. So it stores in that format. in that. So there is an algorithm and all these things, we can go deeper into it, but imagine it is not a text which is going to be stored here. It is a pure floating number array which gets stored here. Now when you have a prompt, let's say I want to know the next cricket match between England and India, what we need to do is that, because now it is not anymore text, so I cannot match text with text, so I need to convert it to a vector representation so that I can match. Okay. We can do hybrid also, but we are not going in that. But let's say we do a vector. That means whatever text I provide, I first convert it to a vector and then match it here. Now it gives me some record back. So you get some extra information apart from your prompt. And next time, when I'm hitting this LLM, I use this as my data source. Imagine, you have petabytes of data. You cannot send the petabyte every time you write a prompt because you have a token limit. Even few megabytes will exhaust your token limit. So you now rebuild the prompt using the data and then hit the LLM. Which means now LLM has those inputs which are very specific to your organization, and then it will give you the result. And that's why you see in the Bing, you are able to find that information because Bing is actually doing that travel. So it is not hitting the LLM directly, it is hitting what is there in the search database of its own, and then fetching those relevant information based on the keywords you have mentioned. Probably it is doing a hybrid search, so both keyword search as well as semantic search, and then it is hitting the LLM with that modified prompt with the data, right? And I'm going to show you that how it looks like in code, because at the end of the day you have to build the code, right? So you got the idea, right? By need. So a couple of things you know, right? You need a web hosting platform, for sure. Because if it is a website, you need that. Either a container platform like Kubernetes or anything of that sort. You need a vector store. It could be anything. It could be like Azure AI search, which used to be known as cognitive search, as a vector store. It could be things like your Redis. It could be PostgreSQL. These are all the databases which support vector format. So anything which works for you, you can take it as a vector store. And they have a standard way of storing it. There is a indexing mechanism you have to apply. It's like massaging the data, making it ready for your RAG. So RAG needs a little bit of work behind the scene. It's not ready-made, plug and play, right? So once this is done, right, you constantly build a pipeline to push the data when there is a change. So for example, you modify a document, let's say you get a resume for an internal application. So we do internal application, right? And then 6 months down the line, I change my resume and give the resume. So definitely there is a change. So it needs to be updated in that RAG, right? So that's when it keeps happening. So that's behind the scene, it is happening. The application should not be worried about it. It gets a ready-made vector store with the relevant data in the format of vector array. And I'll show you how the vector array looks like in the code when you do the vectorization using the embedding. Now, definitely there is a database required, there is a web application required, there is an LLM required. So you can imagine that to build an application, the generative AI large language model is not enough. It is the engine, but you need the tires, you need the chassis, you need the body, you need the airbag, you need everything else you need for a car, right? Same thing here. So imagine that this is not the end of the world. This is just a small part of that big world you are creating, which is the end user who is using it, right? So let me go back to the code and show you. Now, one of the things about this thing is that you can choose any programming language based on how the LLM SDK which you are using supports. It could be JavaScript, that's Node. It could be your Python. Python is most popular, so if you don't know Python, it's high time you learn Python because it will be used somehow, somewhere. And then C# is also another one supported part. So there are multiple languages it supports. I choose Python because it's the most commonly used and it's easy to implement, right? To be very frank. It looks pretty simple.
I have a doubt.
Yeah.
So you said, let's say you talk, let's say hospital is your customer and you say you give me access to all your database, then hospital would never agree to it, right? But then you said I don't understand how would the hospital be willing to provide that data? But let's say that topmost right corner is the private data that hospital won't be willing to expose it to anyone. So, but that still has to go to that vector something, which vector store, which you said is, let's say, from some provider like Azure or someone.
Correct.
So how will the hospital agree to like have a pipeline from this to that?
No, never. They will never do that. So if you do it, I didn't draw it. They probably have built over a period of time called data lake. So data lake is a common dumping ground for every kind of data you are using in an enterprise. And data lake is a common dumping ground for every kind of data in your enterprise, whichever they feel is shareable. Now there are many things which is not shareable. For example, the PII information is, if the employee termination has happened due to some compliance issue, that data is never shared across. It's only very restricted data, right? So those data lake is an enterprise practice. So it started when the big data boom started, right? So many organizations, if you work today, you will heard that they have the internal data lake. That means they have a mechanism and place to create a pipeline to dump the data in the data lake. So there is an agreement between that out of this whole data, I will take 50% of this kind of data from it and let's build a pipeline. So it's kind of getting pushed in the data lake. So we are going to use the data lake, not these common sources, because these are all transactional. Transactional you are not allowed to hit because it needs to be available and secure and only limited to probably API only, not human interaction. So all these things are there. But then the data lake is built over a period of time. That's the data in a typical enterprise. That's what gets lakerized, not from here. Yeah, I have a question here.
Maybe a naive question.
No, I question. We are all learning.
So when we say data lake, as you said, like previously also, previously you said that part means. Maybe I'll go without that. So previously you said that part consists of items that makes up data lake.
Yeah.
And then you also have drawn a part below it, saying that this is a data lake. Is it a concept or is it a component of different things?
So data lake can be, so there are technologies available to support data lake. So it's a big data engine. So you can use Hadoop as your data lake. You can use Databricks as your data lake. So these are technology behind the data lake thing. And it stores data both structured, semi-structured and unstructured format. Because your data can be diverse, right? It's not only relational database, right? Your files also, you have, let's say, video, audio also, that's your data, right? Because let's say your resume is a file, right? So that's semi-structured, unstructured, and then NoSQL data store, basically. So you can think of like Hadoop is a very common big data store. You have got, what I said, like Databricks is one big data store. You have data lake, Azure Data Lake. There is a product in Azure which is meant for the data lake in enterprises. So you can choose that as your store, and then it can contain like petabytes of data with a single storage. And for you to enter, there is only one endpoint. And exit, you have only one endpoint. So it's basically not split across multiple. It is a cluster of things, but you as an end user don't have to worry about it because it has to scale, right? Because your data grows. So eventually, it's a redundant data. So whatever you have here has a copy here, right? So you don't modify things here. You modify things here, and then the pipeline kicks in and modifies things. So it is basically a read-only copy of your data for further access.
Filtered copy.
Filtered copy. So tomorrow, let's say someone says that, you know what, in the hospital, I want to create a report or a behavior how my reception looks like, right? What time people generally come, is it weekdays, weekend, what duration, and what kind of patient they come, that kind of analysis you want to do. You cannot hit their transactional data because nobody will allow you to access it. Rather, you can use the data lake where the data is dumped already and then analyze it. Right?
I think it's like an extension of the data. Earlier we had like
Yes.
individual data warehouses for the purpose of query, and then it extended to collect all the data for the business.
Yeah.
Intelligence having, I don't work on that data.
Yeah, it's similar to that, but because the nature of the data changed, right? It's not only relational, so we had to support other types.
And is Snowflake also one of the products?
Yeah. There was a question from that. Yeah, I will come.
See, there are a lot of options for vector. One is vector store. Another one is just like Elasticsearch. So there are multiple like graph. They say like knowledge graphs. Right?
Yeah.
So there are a lot of options out there. So how do you select which one is best? Because vector is like similarity search. Elastic is like a text search. Graphs is like a knowledge recommendation type of search. So how do we select like which is suitable for us? That is first question. And the second question is LLMs, like we can post on our own GPU, open source LLMs like Llama and all those things. But in case of OpenAI, it is a very big and can't have in our application.
Yeah.
So we will use API. So when I am using API, is the data from the vector search I will be searching and then result I will be passing to the LLM. So will they use my data to train that LLM, or it will be like any SLA will be there where they will not use our data if I am using open APIs?
Okay. So no, it is a read-only model.
Read-only.
So it only takes the data, generates the content, forgets about the data.
Okay.
There is no storage. There is
Training.
there is no training happens because you take a copy. Right?
Correct.
It's like immutable version.
But that is true if I am putting in my own instance, right? But if I am using APIs of somebody, like a paid APIs, like OpenAPI case, it's an API that I'm using, right? I'm not going to put it in my
No, you're still putting it in your Azure subscription. So I will show you like in Azure, if you say that I need OpenAI deployment, it gets deployed to your subscription.
The 1 trillion parameters of GPT-4.
That is a speculation. I don't also know. I haven't seen any official announcement about it.
Okay.
Right? But it's a speculation. However, that thing gets deployed in Azure subscription for you.
Okay.
And the one which you use and the one which I use are two different LLMs. We're not going to hit the same LLM.
Okay.
Because it is.
But that may not be cost efficient, right? Like suppose my application is very simple. My usage is not much. So if I am using GPU machines and putting on
No, it is not going to charge you for the infrastructure. It is going to charge you based on the query you are making. So you build an LLM, you don't use it, you are not charged.
Okay.
Right? So your charge will be when you build the LLM with your prompt and then get the data and how frequent you are doing it, and it's a token based.
So the instance will be different.
Instances are different, yes.
But when you are dealing with the APIs, suppose you have too many. Suppose you have too many of API calls. In that case, it's always advisable to build the LLM model at your end rather than using the API version of that LLM model.
No, even if you build for the OpenAI LLM,
Yes.
which you consider in Azure, is the LLM which is deployed for you to use. So you have a copy of that LLM deployed in your subscription with the URL and a key. And that URL and key is different from the next person who is doing the same thing. So you are using the API.
That's taken, but there are two versions normally the way you can use your OpenAI model. One is via API. Suppose you are a small business and you have a very limited number of queries which you want to run. In that case, it is cost effective to use the API version of your model, whereas there is another version in which you get your OpenAI model subscribed for yourself, in which you are going to, in place of paying by API calls, you will pay by the model. So there are two versions, I think it is there. I don't know about Azure, but we are using OpenSearch in my project.
Yeah.
And it was cost effective for us to use OpenSearch model deployment for our project rather than using it via API, because we used to call it for literally every with 5 TB, 10 TB, 20 TBs of data every month.
No, OpenAI offering, I'm not quite sure because I haven't explored that, but yeah, like what I know, at least from OpenAI, not the open source LLM models, but OpenAI, they do not train on the data you provide. That's written in the agreement, right? You can even go and verify after some time, like whether that data is visible in there. It's not, right? That's the kind of assurance they give you. So it is never trained against your data.
We just completed the GitHub Copilot experience and he said the same thing. So they have some data we use that data for some questions, and if you need give more context, we can give in that specific interaction. We can give
And if you
then
have a
when-
GitHub Copilot
Right.
in your source code, it also reads your code to contextualize.
Correct. You can give the workspace
Correct.
and say that this is my workspace,
No.
and then it will take
Correct.
that data and send to the track.
And I can show you two pages simultaneously, the way I define variable, the convention I follow versus another convention. And GitHub Copilot, if it is creating the variable, it will follow that contextual convention.
Context, yeah, but at the end of that conversation, say I close
Yeah.
the VS code, none of the data stores there.
No, it doesn't go back.
Yeah,
It
it's a
doesn't go
commitment
back.
they give, right? So
Yeah.
it's a, like our company like has that so Divakar, he's from the GitHub, he said the same thing. You don't store anything back permanently there. Whatever
Correct.
we send our code related information goes there for the model to train and
No train.
Yeah, not train, like,
Ah.
sorry, train is the wrong word.
Yeah.
To give the context specific
Correct.
information, but once that is done, that whole thing is destroyed,
Yeah.
is a command.
There is nothing gets stored
Stored.
temporarily. You do not have a log also, whatever your prompt is. So there is nothing like that which gets there.
Yeah.
It's fire and
I
forget.
think that
Yeah.
was a question
Yeah.
that came, right? So
Correct.
we just had that experience.
Correct.
I had
So let me quickly just show the demo because I have got limited time, and then I'll take the question probably later. Okay.
We will be having you for, we will be eating you in lunch.
So let me use the code space. Some time it breaks, hopefully. Now, before you start doing that, right, you need a couple of things. You need an OpenAI deployment. Let me show you those things first while it is trying to load. So you go to your Azure portal and you say that I need an Azure OpenAI, right? And you say you create an OpenAI. Now what happens? An OpenAI instance is created for you in Azure. It's an empty instance. It's nothing there. Now you choose what model you want to deploy in that instance. So it is like a sandbox for you, right? Now you create the instance, you tell which location you want to put that and everything else. It is just a, let's say, container which gets created. Now once this instance is created, right, I'm not going to create it again and then show you that something which I have here, because OpenAI is on high demand, we only have limited access to it. So you can see that you get something like this. That's your API key and endpoint. That's what you need for your application. So that's endpoint and the key which is hidden. These are the two things you need to connect to that API. So you use the same SDK to point to any OpenAI instance you create in Azure. You just change them, it works. Okay, because that's how the SDK works, right? And there's the same OpenAI SDK which you also use against OpenAI. Now after that, you have something called OpenAI Studio, right? And that's where you choose like how you deploy a model and then what kind of things. Let me show you that option also. So if I go here and then I use, let's say, the latest one, new Azure AI Studio. You choose the LLM models. There are choices available for us, right? So you can see that there are a couple of, so you say new deployment. And here you choose the model, which model you want to deploy. So you can see that these are all available models. So you can see that we have a Babbage, DAL E3, that's for image generation, GPT-3.5, GPT-4, 32K, and then ADA is for embedding. So there are multiple different models. Model come and go, okay, which means that you might get a notification that this model will not be supported anymore in next 3 months. So it will change those things with a newer version. So this is what happens, right? So when you say that I want to deploy, let's say GPT-4, so which I already did, and you can see that there is a deployment which is there. So in the SDK, I will give this name called deployment name and the model name, through which it will be connecting to this model of my OpenAI instance. That's what SDK does behind the scene, right? When it queries against it. Now let me see if
So the entire GPT-4 model will be copied over to your GPT-4.
Yes, it will be available to you as a whole deployment.
That's a really huge model.
But we are not charging for the infrastructure. We are only charging for the usage. So if you're not using, you're not paying. It's a consumption-based model.
But it is a multi-tenant.
It is not.
It's not.
No. It's a private deployment. That's why enterprises are choosing Azure OpenAI versus the OpenAI, because then they can protect their subscription with all the policies and restrictions. They protect for everything else in Azure, right? It applies the same group
What's
policy.
the size of that model?
What do you mean by deployment to private model? What exactly does it mean, seriously? I mean, I'm trying to take it from the perspective of
So you
Azure person.
have a folder of MP3 files, music.
Right.
You copy that folder to your laptop. That's the private deployment. You don't point to that folder to listen to the
In the
song.
case of the AI model,
Ah.
what does it really mean in practice?
So AI model is a neural network. So it has got nodes where the memory is stored. So think of it like a graph, like it's like a tree of flowers where the data is stored. So that's why the more parameter it supports, the larger the size is.
So what's the size of the opening? So what's the size of the?
It is not documented. So whatever you see is all speculation. So I'm asked not to. There is no rough because there is no documented thing. For any closed LLM model, there is no such thing. It's only
What is the
speculation.
size? What is expected size of those models? That because see, if I'm saying that I'm deploying one thing for everyone, means that if it's a few terabytes, that means that many number of terabytes is being deployed to everyone.
That is there. It's a hyperscaler cloud.
See, we all know what the cloud is. So I mean, yeah, the cloud is there, but it's not infinite. We don't have an infinite cloud. There are obviously certain resource constraints and all this. So it's a billion parameter model. If it is a 1 TB, so every time somebody wants that, are they really deploying a fresh copy of that, or are they actually deploying other techniques which ensure the data does not leak? Which is the point. Is it really a separate thing, or is it something like what do we have in Docker container? The underlying kernel remains the same while you have different applications. Is it that sort of a model similar to that, or is it the pure virtualized model?
No, it is private deployment, as I said, a copy of your thing. But the infrastructure is not charged to the customer. It is the hyperscaler who takes care of the infrastructure.
Okay. So instead of charging you that 1 TB, well, as long as the model is running, while your VM is there, you don't charge it this.
You don't charge. You are not getting charged for the computer.
Is it for
Let's
the-
put it that way.
Is it for the enterprise sounding like or?
It's what Azure, how it works.
Like, I think strategy especially is like being higher than regular customer, regular pay card, credit card. Will I also get a copy of it or is it also?
Yes, it is for everybody who is using it. Same. Yeah. That's how the privacy is come. So if you work with highly compliant industry, these are the questions we get, right? If we say that, no, we have common deployment and I just let you use it, people will say, thank you very much, I'm not going to use your model. Okay? So we cannot do that for enterprise customer. Everybody needs their copy. And that's how hyperscaler has to support the model, right? Because if you think the data, right, it's a simple storage. If you have 1 petabyte data, we keep 2 more copies for you, but we don't charge you, just to give you the high availability. So that's the burden and any hyperscaler today has to take to provide the service.
They don't charge you, they don't charge you for the storage.
They charge for the storage of your file size. So there is a written
Right.
price
Right.
written to it.
And if you really look at cloud computing cost, whatever calculation they have done, storage is the most expensive thing in the cloud. Compute is not. Compute is virtually free. It is storage that is there, that is what they charge you for. And they charge you basically because they are copying 3 things. So that 3 thing redundancy is actually not free. It's embedded into the pricing model. That's what I just want to point out.
Is it okay if we take that offline,
Yeah.
that discussion?
Yeah.
No, I know there could be a frustration, But at the end of the day, it is how it is, right?
It's not about frustrated, it's just about saying
No. I think like we need to discuss it in more detail. If you see the chart, it is in cents. For 100 GB, it is few cents. It is not that costly. Storage is the cheapest solution. Compute is not cheapest. So how we take it, like we have the API, we have the key and the endpoint, and we can just connect it. So the code here, I just wanted to show you that. I haven't got an environment file. Let me see if I can increase. Yeah, so you can see that I'm just pointing to the API key, I'm pointing to the endpoint, I'm pointing to the version. Correct? Now I'm going to run this. And it just sets my environment ready. So I'm running in the, let me just hide a few things. Yeah, I'm running it in the Python notebook. It's easy for me to run and explain. Now what I'm using behind the scene, I'm using Azure AI Search. There are some commented code, so just ignore that. I'm using the Azure AI. Now we can take questions.
See, it's a multi-language support. See, generally OpenAI says that they support multi-language, right? So in Japanese, suppose let's say I'm putting query, it gives the response in Japanese language. Correct. So we tried that. But there are some people who are developing the foundation models from the scratch for that particular language. Like some people developing for Tamil and Telugu. So with your experience of working with multiple people, do you suggest the same open API for multi-language, or you suggest something else? Generally, how is your experience working?
There is no language in the LLM, to be very frank.
Language is not. Training has to happen. Right?
No. It's the data which you provide.
Correct.
So for example, if you train the LLM with only English input,
Correct.
if you start sending the Tamil, let's say, characters, it will not identify because there is no vector representation for Tamil LLM. If you have to train the model with all sort of inputs which you want your model to support. Now there is no language because the moment you vectorize it, there is no language. It's only an array of floating points. Okay, so that there is no language per se in the LLM. So I can type any language, and if it can match, it will get me the data.
So correct. So for Indian languages, so how?
I will take that maybe later. So I just wanted to quickly show you that. Is that I've got a couple of files which I have put in the Azure AI Search. So that's the vector search I am using. So if I ask this question, now let me show you quickly also what is there in the. So you can choose any vector search. You can choose ChromaDB, you can choose Fias, and you can choose any vector search store. But I just have a vector store. So what I did, I went to the Bing chat and I said, describe write an article for Leonardo da Vinci, and it produces some content. I copied it and then put it over here. So up here. So if I go to the AI search, and I have got a search created, and I am going to show you, because this indexing takes time, right? So there is a block store where the data is stored basically. So if I go there, and you will see the detail, but let me just show you the indexes quickly. You need to index, otherwise it will not search. So I have got a DevOps white paper, and Devon, I don't know what I think it is an OpenAI white paper, which is there. And then this is vectorized actually. So I will show you the fields, Search Explorer, and I say that open. This is just a test whether your index is properly done or not, right? Can it fetch the information? So you can see that it fetches the information from a large document which is chunk for this AI search. So I basically split that document into smaller pieces to embed it so that I can stay within the limit of token, and then that is getting stored in a form of, let's say, the content vector. So this is the vector how it looks like. So it's an array of floating number which is of 1500 plus dimension. That many characters are there. Now, if you have a word or a sentence, the array size is the same. It is the same, and I'll show you that quickly. Now, if I may go back to this, and what I'm trying to do is that I'm trying to say that who is Leonardo da Vinci? I was going to run a semantic search. Why semantic search? I may be writing all the words which is not at all present in the word. It will find the meaning for me. So that's what semantic search is doing, right? And then you can see that I'm pointing to the content and key phrases because there are something in the AI search called skills. So you can say that how the document will be vectorized, what skill it will use. So you can use different skills like I want the keywords, so vectorize only the keywords. I want a very domain specific, let's say ML model to figure out the things. I can do those skills. So those are the background work which is done already. So let me search and see what it brings, right? And you can see that because it is not an application, it's fetching me some raw data. So it is saying that some classic American stakes, high stake, diverse. Why? Because there are other documents also clubbed together. So I made a junk document alongside the Leonardo. I said what are the restaurants, I put that in the document. Because it is finding in the same document, it's trying to retrieve you that. So when you do a search in the Bing, you will see that 1 of 30, 1 of 0, 2 of 30. So these are the option and choices, right? So you basically get multiple output when you do this keyword search. Now let me use this YouTube, and then what it now is doing, instead of going into the direct search and doing a semantic search and fetching information which is not relevant, it is now taking your question here. So you can see that, and then it is also finding the documents which is relevant. So that is where RAG comes in. So now I'm saying that you don't hit the search directly. You build a prompt based on the keywords you get from the search, and now hit the LLM. Now let's see the difference, okay? If I run it. You don't ignore it, see, it's a LangChain thing. Now it is fetching me some information, right? Let me copy the whole thing and try to show it in the notepad. So this is now it is fetching. Now you see that it is more meaningful output because now I'm not returning just the keywords coming out of the search. Earlier it was returning only the keywords. Now I'm sending those keywords which came out of the search to my LLM to build the meaningful thing out of it. So now it knows what data to play with. It is not going and fetching everything. Now if I ask the same question to my LLM, who was Leonardo da Vinci, it will probably give me more information which is probably not there in the word. But I wanted this to be grounded against my data. I said that you don't go and fetch the information which is in the public internet, but stay within the context of this. Because Leonardo could be an employee of an organization, which I'm not going to fetch the information from an artist Leonardo, but the employee. So how do I make sure my LLM stays within the context of the enterprise is where the RAG really comes play handy. Rather than.
Do you know what is what was sent to the LLM?
Yes. So in the code, if you see here, I am sending this docs. So if I can print the docs here before this.
Both question and docs, right?
Both question and docs. That's how you ground it.
Right.
So you say that this is my question, but get me the answer from this doc. Query. Docs.
Template format remains the same.
Template, no, you can build a very complex template by yourself. So it's like a placeholder within a large text. You can say that get me the answer in a tabular format where I need this field. So that's part of the prompt, right? So you can give the instruction. So there are multiple ways to do a prompt engineering. You one shot, few shot. So you can say that in one shot, tell me the sentiment about the Leonardo, right? Whether it's a positive, negative. So it will also get you those information. What is the rating as an employee of the thing? So get me all those fields in this format. So you can tell that. So it can be very complex. Not sure if it is fetched. Let me see. So let me get that. This is the docs. So I'm replacing the docs placeholder with the docs data. That's why I need to print the docs data. You can see that the docs is getting replaced in the doc data. So I'm going to print the docs data for you.
Also, please.
Query or the query, okay. Alright, let's see how it goes. So this is the docs data, the first line. So this is the data coming from your store. Let me copy it from AI search. I'm not using data lake. So this is the data.
But this data doesn't have anything about Leonardo.
It doesn't have anything about Leonardo because I think it is hitting the wrong word. Because I have mentioned that the temperature needs to be 1, so which is more dynamic, right? So you can control that. Now there is a parameter in the LLM SDK which is called temperature, which can tell you like that you set the temperature to 0. That means don't hallucinate. That don't bring me anything which is not in the document. If I say that, the LLM will not be fetching any information. It will say sorry, I cannot find. And I will show you that demo. Okay, that's exactly the demo I wanted to show you. So hallucination configuration is important. So let me quickly go back.
And where is the documented data of the organization is stored?
Right now, for the demo, it is stored in Azure AI Search. It's a vector store where I have kind of pre-populated the data with some dummy files.
So if I want to do this ourselves, we can upload our files and it will create a vector store out of that.
Yes, you can do it one-time upload, or you can build a pipeline for continuous upload.
Can you also create that vector store on a local machine?
Yes.
And then upload the same?
Yeah, you can practice it, play it with the local machine also. There are open source vector store available. So for example, it's an application which is I created. So you put an URL of a video, right? Any YouTube video. It goes to the video, gets the transcript of the video using LangChain, and then gets you there. Now here, I have grounded it to ask this question. Now if I ask this question, tell me about the weather. Okay, this video is about natural language processing. So just a 5-minute video, I think from IBM, Artificial Intelligence and Natural Language Machine Learning. And this is very specific to GPT and natural language, and you can see the summary of the video, right? It's coming. Any video you can put, it will get you that. Now if I say Control Enter, so you see clearly it is saying that answer to the question about weather is not provided in the given text. That's what we call grounding. Now if I have made it towards 1, that would have hallucinated and gave me some information about weather, maybe a song or a movie or anything of that sort. Sometime in the content world, this creativity plays a critical role. So we don't always deny the creativity. Depending on the use case, you choose to have a creativity or not. Or say that stay grounded, don't creativity because it's a very financial information, I don't want you to create and build some figure for me, stay within the context. So you can ground it. So by choosing the temperature parameter of your LLM SDK, you can say whether it will fetch Leonardo or not. If the data is not provided with anything about Leonardo, it will not fetch it. Right? It will find probably no response.
I have a question. So example that if Leonardo is another person, so let me take the example that Vladimir. So in the recent context, Vladimir Putin is a president of Russia, also Vladimir Zelensky is president of Ukraine. So how about this case, if I tell that who is Vladimir, then how the result will be interpreted?
So it depends on like the proximity search it does. So behind the scene, in the context of vector space, imagine it's a three-dimensional space. It's easy to let's say imagine three-dimensional space than 1500. It will be cluster of words if you consider them as word, though they are not word, but think of it they are word. So Vladimir can stay close by, and in the vector space there is a cosine similarity which happens. That means this angle between these two, what is the theta and what is the cosine. So you know that when it is matching, that is 0, cosine 0 is 1, right? Cosine 90 is 0, and then more than 90 is negative. So that's how you find it finds the weightage between the words, how close are they, and it gets you all the closest word out of that word cloud. So when you send a prompt, let's say who is Vladimir, that's it. So it will search who, so it will ignore who because it's just a common task. Vladimir is the word, so it will find all the Vladimir. So maybe it will have a word cloud for each country. Vladimir in Russia, Vladimir in Ukraine, right? So it might find the distance between two Vladimir, right? And it might pick up both of them and give you both the choices. Now it's up to you to select. Now that is where we do the testing, like how it is reacting to my data, right? And do I need a further, let's say, embedding? Can I modify that behavior? But at the end of the day, imagine it's a cosine similarity which happens behind the scene, because Azure AI Search uses something called hierarchical neighboring small word, HNSW algorithm, to store the data in a vectorized format. So when it stores in a graph way, and then each of the node of the graph, that's how you traverse, right? So you don't travel the nearest graph, you have a path defined, and that path is designed based on the algorithm which I told. It's a standard algorithm, it's not Microsoft created, and that's how it is stored. So you can choose which algorithm to store your data, based on which the data will be clubbed together.
Do I access the temperature at runtime or during the call?
You can do it in runtime. So when you configure all the SDK, right, LLM, that's when you set the parameter. So every time you can change. So you can have a toggle, like, so you have seen in the Bing, right, creative, precise, there are 3 options. That's the temperature. So you can change it dynamically.
When you say hallucinate, what does it hallucinate? What data does it hallucinate to? Like,
it's training data, it's memory data. It has its own memory, right? There is some data in the memory of the LLM. It populates the information from that memory.
Will it also take the context of the chat that somebody is writing?
Yes.
But he might be searching earlier where is the Ukraine. So will it take the context of that? Okay, he might be looking.
So that is not the feature of LLM. It is the feature of the application where you keep the history in the memory, and every time you do a further chat, that's how chat is built, right? It basically takes the context. So that's when you need orchestrators like LangChain. So LangChain can keep the memory in the buffer and keep providing the memory as you proceed. Right? You say end chat, that means the memory is clean. So that is not part of LLM. Because LLM is only what you provide as a prompt. So in that prompt you have to provide the history also.
So in the first case, when the Leonardo returns us information which is not relevant, are you also using that information for further processing?
No. It's just a one-time gate. So I have a document in the search called Leonardo. It is not getting me the information which is relevant to the search I made, right? Because it hallucinated. And I showed you the second example where I kind of ground it and say, no, don't give me answer if you don't have that data.
But the intention was get relevant information from your document
Yes.
and then use it further.
Correct.
But since it hallucinated, you have some logic written to not use it if it hallucinates.
No. There is a parameter called temperature in the SDK.
Yeah, no, I got that. Because the parameter is one, it also returned irrelevant information.
Correct.
But what I'm saying, whatever it returned, you need to use it further for search. If the parameter was not one and if the information returned was relevant, you would have been using what the Leonardo search returned for further processing. Right? How do you decide like if to use that information for further processing or not? On what basis?
So it is definitely an application decision. So
yeah, that's what I was saying.
yeah.
That it's some kind of design or logic of that.
Correct. It's a flow of your application. So for example, you want to do a further validation like whether it is relevant to you or not beyond what LLM returns you or the data returns you, right? That's an application call. You can always do that. So there are certain, like you can say that I only allow these keywords to be worked. So you have a data source which is, so you do a matching. So we use a lot of like Cosmos DB kind of NoSQL data source to match the data. For example, if you have a product search in Amazon and they are using LLM and that product doesn't belong to the Amazon store, it will not say page. How does it validate? So it might validate with the what are the products it is returning with the whatever products they have, and then will tell you only the products which is there in the store, right? So something like that, which is an application flow.
Yes. So but can we run that Leonardo thing against the actual data that is there in the document?
Yes.
Instead of it hallucinating and giving us random stuff, see how well it will actually perform.
I don't know whether we have a time to do that, but let me just check. We have time.
I think this is so far most interactive session that we are experiencing. The topic itself is so interesting, but I think we can also sync up after when we have some gaps, some breaks, and we can get our query clarified, as well as Wriju will share his email ID and he has his LinkedIn profile, so you can directly contact him.
So let me put it in the screen.
So that would be helpful, so that we can move on with the agenda.
So OpenAI needs a full day. So when I
it's not simple topic.
When I do the MVP with the customer, I book 8 hours plus 8 hours. That is to prepare them what I'm going to tell. That's a day before, and the 8 hours to brainstorm what they're going to do, not even to build an application. Okay? Because there are so many doubts and queries, we need to first clarify before we start writing the first character of the code. So that is what it is, right? It requires a lot of brainstorming and input and all these dependencies. Right?
Basically, you have to be a vector DB yourself and get ready for all problems.
Yeah, there is a preparation that also required some pre-session.
I just one small thing. So we know कि ChatGPT, for example, is kind of slow, like when we are getting an answer from it. So do you have any benchmarks on what's the speed of ingestion of data? For example, if I'm giving it a huge file to ingest, so is it very slow? Is it, when we are retrieving the data, at that time we can see that it's loading. So for ingestion, do we have any benchmarks or something?
No,
because for example, Bing has tons of data to ingest. So, I'm curious on how it is ingesting all of that.
So that is happening back of the scene. So that is not happening when you write the query. Because if you are planning to do that, when you write the query, you provide the file, that will definitely be slow. Right? So for example, if I may just quickly show you this thing. There is a small sample I created where I will show you this. I have got a folder called movies. So what I did, I went to IMDb and copied the content of the movie, right, the rating and all these things, and I created a lot of MD files. Now imagine that you are searching about movie and say that you stay grounded to the movie on the fly at runtime, right? You don't have a vector store or anything of that sort. Now this is the prompt which is going. That means all the movie which I have written in MD file, couple of I think 11 or 12 there, are going as part of the prompt, which is basically causing me the token limit issue. So I am hitting the token limit, and I could have shown you that you will not get the output. So imagine that this is the only small amount of data, right? And this is exhausting your token. So that's not an effective way to hit the LLM. The effective way to hit the LLM is have it stored in a storage and use that query to fetch only the relevant information and then hit the element. So your prompt size remains within the limit of the token.
So initially we create a vector store out of whatever data we have. Have a local search, identify the key concepts that are there from the vector store, and then hit the LLM with that to get the actual.
Correct.
That's the way you see it.
Correct.
So part of it can also happen locally within the enterprise.
Yes.
So that the enterprise people only hit the LLM with the specific without exposing the entire data.
Correct.
Right? That's the whole idea, a lot of the idea.
Ideally, if you see, there is a co-pilot for Azure. Now, co-pilot for Azure is a OpenAI implementation for the end user to search anything in Azure. Now, there is no vector store. What it does, it uses your login and checks what authority you have to access that Azure. Are you the simple reader? Can you access this resource group, that resource? Do you have modify right, read write or write? All these things it checks and then fetches you information. So basically does a API call. At the end of the day, it does the API call, fetch the information and then on the fly they vectorize it, creates a prompt and gets. There is no store which is constantly doing, because there are millions of Azure users. It is not practical for Microsoft to build a store. Maybe I will never use Copilot. And so what is the whole point of having a store created for me, and then if I use Azure every day, then I have to rebuild the store every day, right? So it is an API call. So when you have an enterprise, it generally makes an API call to the store. If you say that I want to get my HR data, at my all past salary information, vacation information, everything, that's an API call based on the context of the user. So if you are authorized to access the data, then only that API call can fetch you the data. Then it will vectorize it on the fly and then match the prompt and create a further prompt and proceed. So there is no store in also scenarios like this.
What is the cost of vectorization?
Vectorization causes you a couple of costs. One is that the store where you are putting that vectorized. So if it is a licensed product, like if it is Azure AI search, then there is a cost for Azure AI search. There is an indexing cost. There is a pipeline cost that constantly you pushing that, right? And also the embedding algorithm you are using from OpenAI. Because you have to use the same embedding algorithm to do the vectorization of the data plus the vectorization of your prompt, because it will otherwise not match. If you use two different algorithms, it cannot find the information. So
that is up to me. For example, my prompt is going to vectorize and it is going to search for the matching context in my data which I already have vectorized.
Yeah.
So this vectorization is...
So whatever algorithm, so vectorization doesn't happen automatically. So to say that this is the algorithm, like LLM, there is a open source vectorization model available called Word2Vector. So you can use in Python. Right? It's a very nice thing to play around. So if you use that, you need to build that vector database using Word2Vector. Otherwise your prompt will not match, because two algorithms are two different output, right?
But the LLM does not define any algorithm like that, right? It's only looking at vectors. Whatever we do locally, we can use whatever algorithm, but ensure that it matches and then we can support it. So that's what you're saying, right?
I'm sorry to interrupt, but I think we should go with the agenda, and also I think many people are interested for coffee break. We should take break before we begin with the next session. So Wriju, I think this was one of the most interested and interactive topic that we have seen, and this is really nice. So Wriju, anything in the thing that you want to show?
No, I think like we are good. So, but this can continue, right? This can
share the GitHub URL.
Yeah. So I'll put the GitHub URL in the slide, and then I'll share the slide so that you can go to the Meetup and then download it. I think right? So I'll share the slide today. So I'll put a couple of links which we have created some samples in Microsoft, which exactly talks about the enterprise data, how you chat with the enterprise data. Because
using free account we can test. Using free account we can test, or we need a license.
So
Azure OpenAI should be free.
no, it is not free. That's all. But you can use the open source LLM models also to play with the same thing, concept. Right? Conceptually, it is same. There is a hack, by the way. I found a hack yesterday only. There is some hands-on skill test available for OpenAI in Microsoft. which allows you to go into a portal for 2 hours. You can create an OpenAI instance, deploy a model, use that key for your application. So it will be available next again after 72 hours. So if you are really keen to try some code, you can use that key to deploy and test, and then you are good that way.
I think even learning for a test, etc., those learning materials, I think they provide some sandboxes.
But most of the sandboxes they provide doesn't have
the plants are falling, okay. I think the plants are also tired. Yeah, I think in interest of time, I'm really sorry about it, but in interest of time, let's take a break.
Thank you so much.
Usually,
so I want somebody to take a picture actually.
Yeah, please.
Big round of applause.
So guys, I think the usual format is that we